Hi. Well, here's your talking head again. Basically, I want to talk to you about, or introducing the subject of Chapter 2 in Kaufman and Cummings' book, and in our class of astronomy. Now, the basic topic is one called gravity. And what ends up happening is in the first week or the second week of the astronomy class, actually, once we get started, at some point we need to talk about the history of astronomy. We don't learn everything we know just from revelation. Basically, we learn things from observation, and those observations also can be from the past. And so those observations are written down for us, and we can reproduce their observations as well. And so I would like to talk about those things in a reference frame of talking about gravity. Basically, what we'll be seeing is several PowerPoints about particular subjects, and these subjects refer to the history, as I pointed out. The second one is a special one having to do with the Greeks. I get goosebumps when I talk about the Greeks in my face-to-face classes, and maybe you'll get this sense of just astonishment that I have about these folks. They were the ones that we assign as being the first ones to say that nature or things that happen around us are not caused by some sort of god from Mount Olympus or some other place sending thunderbolts and nailing us, if you will, unless we give them a good sacrifice or pray to them or something like that. Instead, we can understand the world around us by laws, and everybody has to obey them. And not only us, but natural things, rocks, and other animals and critters around there as well. And what we'll find out during the course of this astronomy class is that there are some basic rules, and some of you have already sort of gotten the implication that this is really an astrophysics class. Astronomy and physics are tied at the hip. That is true. But that shouldn't be frightening to you. On the other hand, it should be it should be very pleasant for you, because the understanding that things out there, getting my hand in the picture, things out there behave the same way as things down here do. Okay? That there is no dichotomy, there's no differences between what happens in the cosmos and what happens here on Earth. A lot of religions seem to think that heaven and hell and Earth are very different places. That might be, but that's sort of in an ethereal sense. It isn't a natural sense. Okay, wherever we look out there, it's behaving according to the same rules that everything down here behaves with. Everything falls according to gravity. Everything moves according to charges, electricity and magnetism. Your cell phone, me talking to you on this thing, and you being able to listen, all going through electronics. The sun operating with fusion and fission in order for us to see during the daylight. So all those things are natural rules. And the Greeks sort of set us on this course of understanding nature that way and viewing the world around us in this natural way. So that's why I get excited about it, as I can go on forever about this topic. Now, the other things we're going to be talking about is this transition or the transition through the Middle Ages to the Renaissance, and talking about Galileo, Tycho Brahe, and Kepler, and then leading up to Newton. Now, these topics are basically to give us the understanding of where gravity came from and the big change that occurred around that time, especially with Galileo's observations, that the Earth did not was not stationary and did not move, but actually went around the sun. Now, when I say actually, I mean something in a slightly different way than what you're normally used to. I mean in a hypothesis way, a scientific way. And what I mean specifically is that if you believe that the Earth goes around the Sun, or you believe that the Sun goes around the Earth, those are two different theories, and we can test them. Those that believe in the flat Earth sort of have the tendency to believe that the Earth is stationary, does not move, which is an obvious fact, if you will, and then the Sun goes around the Earth. Okay? So that's one hypothesis. Now, though that hypothesis leads one to have some expectations about observations that you can make. Simply put, what happens to the Sun at night when the Earth is flat? If the Earth is flat, then you would expect to be able to see the Sun even though it's far away. It would be close to the horizon. Does anybody observe that? How far away is the Sun? Is another question you can ask. And I've done a little bit of study of not ancient, but historical flat Earth documents. Basically, the thing started in 1850. And they come up with a variety of different altitudes for the Sun. Some of them being 700 miles, others being 3,000. Basically, even if you put the Sun at particular altitude, then you could move back and forth on the Earth a certain distance, and you could actually test whether or not that altitude is correct, in the sense that, can you observe the effect of that? All right, so let's getting back to Earth going around the Sun and Sun going around the Earth. It turns out that Galileo made some observations that you can explain given a Earth that is the center of the universe. And we'll find that's the case for all sorts of observations in the future of this class. Okay, so major topics here are going to be history, various ideas from various societies out there, or civilizations. Then we'll be talking specifically a little bit about the Greeks, and then we'll be going into the measurements of Tycho Brahe, the measurements of Galileo and Kepler's analysis of that data, and then we'll go and talk about Newton's 3 laws of motion, and then we'll talk about Newton's crowning achievement, if you will, his universal theory of gravity. Basically, the idea being is that everything up there behaves the same way as everything down here. All right, so that's the point that we're going to try to get across, and we'll talk more.